Hi students, let's look at this question which is on integration taken from the year 2023 paper on question 4. Let's see how can do this proficiently. So the first part is pretty okay. This is just using factor formula to solve it, right? So let's see how can do this. So take it out from MF26, we have got this this factor formula here. What we need is actually cosine and cosine. So cosine and cosine is actually the third equation here. Now the reason why we use factor formula is because at this juncture here, all these are integratable. Okay. All the left hand side, all these can be integrated, whereas from the right hand side we can't. So basically that's it. What we do is for first part, integrating cosine px cosine qx, what we do usually what we will do is just add a 2, just multiply by half, then 2, and cosine px cosine qx dx. So from the left hand side here, what we need is to get to the left hand side here, what we need is to get to the p and q here. Now take note, when you add both of these, so basically this px here is your half p plus q, and this is a half p minus q. So if we take half p plus q, and this is equals to actually your px, right? Now qx is equals to half p minus q. The way to use a factor formula is that you add both of them up, simultaneously add both of them up. The amazing thing is that when you add both of them up, this will be px plus qx is equals to half p plus half p. The half q plus minus half q will just cancel each other. So this will be left with a p here, capital P. Then if you take half minus 2x, then this will be px minus qx. This will be q. Okay. So essentially, I solve for the p and the q by just adding both up and minusing both out. So this case here, this will be half cosine p, which is actually px plus qx, plus cosine q, which is at px minus qx dx. Okay, that's it. So add these both up to get this, a p, then minus it, we'll get this. So the rest is just factorization and try to integrate it. So cosine p plus qx plus cosine p minus qx dx. So integrating this is pretty okay. This is just half. This will give you sine p plus q. Remember to divide by the coefficient of x, right? So it's p plus q. Then for the subsequent, similarly, you get sine as well, p minus q x over p minus q. Okay, so this is the integral here. Great, so the first part done. Then we're going to look at part B. Given that n is not equal to 0, show that cosine x cosine nx is given by this. Okay, where c is an arbitrary constant. What we could do is actually just what we call it by parts, right? So what we do is x cosine nx dx. Okay, we know that Liate, if we use Liate, this will be our u. Okay, and then this is our dv dx. Now the reason why we let this be our u is because after differentiating the algebra, it will just disappear. Whereas for cosine is a repetitive function, you keep integrating and you get back yourself, so it will go to nowhere. So essentially this is x, so du dx be 1. Then dv dx here will just be cosine nx. So integrating cosine nx, what we'll get is v is equals to sine nx over n. All right. So then we just uv minus v du dx, integral of v du dx for by parts. So u multiplied by x will give us x sine nx over n minus of v nx over n dx multiplied by 1. So this case here, I'll get x sine nx over n minus of minus cosine nx over n plus c. Oh, so we get what we were told to show. That's good. Plus cosine nx over n square plus c. Okay, that's it. So let's look at part C. Part C, using the result on part B, show that for all positive integers, so meaning n is equals to 1, 2, 3, 4, 5. Okay. So the value of 0 to pi for x cosine nx can be expressed as this, okay, where the possible value of k are to be determined. So let's look at this, part C. If I were to put my, what do you call it? This is 0 to pi. Okay, so what I'll get is, this is definite integral, so I'll get this guy here. The previous answer from B, nx over n plus cosine nx over n squared. Then this will just be pi 0. Okay, so we put it in, it'll be x sine n pi over n plus cosine n pi over n squared. Then this is pretty okay. Then minus of x sine 0. Sine 0 is just 0. Then cosine 0 is also just 1. So essentially this is just this is okay. We can solve this substitute here, but the problem here is this guy here in this middle here, right? So I mean the first part here. So sine n pi over n plus cosine n pi over n square minus 0 minus 1 over n square. Sorry, this is plus. Okay, great. Okay, great. Now, what we need to do is to understand that this is a multiple of pi. So, multiple of pi as well. So, if n is basically this, okay, we know that np, if n is equals to 1, 2, 3, 4, okay, so n pi will just be pi, 2 pi, 3 pi. This is multiple of pi, right? So we know that sine multiple of pi, okay, 180 degrees. So 180, 360, 520, 540, and so on, will all be 0. Okay, so sine multiple of n pi will just be 0. So this will just be 0. Then cosine n pi, for this case here, cosine pi will be -1, cosine 2 pi will be 1, cosine 3 pi will be -1. Okay, so but anyway, what we could do, if say in exam you can't really think of this, you could just use a GC and just evaluate. Okay, so bring out a GC. What you need to do is for the function 1 you just put sine n pi, and then for the function 2 you just cosine n pi. So here we go to sine n pi, sine x pi. Okay, then after which this guy will be cosine x pi, cosine x pi. Okay, then you second table, you'll be able to see that, okay, this you have to know is 0. These are all 0. So it's 1 minus 1. So from n equals to 1, is minus 1, 1 minus 1, 1 minus 1. This case here, so when n equals to 1, this all 2, 3, they're all 0. Then cosine n pi will just be start with minus 1, 1 minus 1, and 1. Right. So the n, when n is odd, is -1. When n is even, it will be 1. Okay. So we that's how we do it. So here, when n is odd, we know there's x0 over n plus -1 over n square minus 1 over n square. So this will yield -2n square. When n is even, we know that this will be x still 0 for this guy, sine n is even, but cosine even will just be +1. So just be 1 n square, right? Then minus of 1 over n squared. This will be 0. Okay, so this case here, just remember, you can either understand it from perspective of a multiple of pi, then you use your trigo knowledge. Or not, you can just use GC to evaluate. Okay, but you just have to be mindful of that. So I'm going to write this down. Okay, I'm going to write this in piecewise function. So when 0 to pi x cosine nx dx, it will be -2 over nx squared when n is odd, and then when n is even, it's just 0. So you can look at D. Using result in part B, find the exact value of x cosine 2x dx. So I think the first thing is to just plot the graph first, and to know that now you're looking at n is equals to 2, which is actually even, right? So we're going to eyeball this guy here, the even function here. I think this even function, we need to use this. Okay, so I'm going to look at this guy later. Then the other thing is also understand when it's modulus, you have to rely on the graph. If you don't draw the graph, it will be very difficult. Okay, as in it's not really the right way to do it. So for modulus function, what we need to do is just draw the graph of say modulus x. So math number absolute value, then we just x cosine 2x. Okay, let's bracket it. Then what we're going to do is just zoom standard, and this is a graph here. So, but of course, we want from 0 to pi over 2. So I'm going to zoom box to the area that 0 to pi over 2 is roughly here. 0 to pi over 2. Okay. Here. So, here, 0 to pi over 2. So maybe in my window settings, my y min, I can put like -1. And there you go, this graph here. So pi over 2, trace pi over 2 is this value here. Maximum point here. Okay. So what we need to do is y equals to modulus x cosine 2x. Here you go. So we want from 0 to pi over 2. Okay. Now the main thing is to understand which part of the graph is being flipped up. If you're not sure, what you do is you draw the original graph without the modulus. So let's say this is x cosine 2x. Okay. So this guy here, when you graph it up, you see this guy. Okay, so of course it looks very what do you call it? You can put it as dotted, then the dotted one will looks nicer like that. Okay, so these are the original graph here. We know the original graph is this one. So this is being flipped up. So in other words, this function here, because this would have y equals to x cosine 2x or y equals to -x cosine 2x. The one that's being flipped up, the original curve is this guy, and this is the original curve. The one that's being flipped up will be the negative function, right? So from here, what I know is this function here is actually y equals to -x cosine 2x. Okay, then whereas this guy here will be y equals to x cosine 2x also. So basically that's it. So we need from 0 to pi over 2. This is pi over 2 here. Okay, this guy here would be likely pi over 4. Just check, it's half of it. Half of it. So pi over 2, you just check, just trace, put pi over 4 here. Okay, you need to find this value here. There you go, is y equals 0. So we know that if you want to find the integral of 0 to pi over 2, the modulus is x cosine 2x dx. What we need is 0 to pi over 4, taking the positive function, okay, break it apart. So this is x cosine 2x dx plus 0 to pi over 4 to pi over 4 to pi over 2, take the negative function because it's under the negative function, is -x cosine 2x dx. Okay, so this is the first thing you must be able to confidently do before you even start. So actually we can't really use this pi then, because this pi is useless now. We this is 0 to pi over 2. And so we can use b again. So I'm going to use the integral for b. Just do it, put it in. What we have is this guy will be from b. This will be x sine, the n is 2 now, so sine 2x over 2 plus cosine from b over 2 square, which is 4, pi over 4, 0. Plus this is I can put a negative outside if I want to. Then I copy the same function from the first one. Plus cosine 2x over 2 square, pi over square, pi over 2, pi over 4. Okay. So some of the special angle here we just substitute in. I'm just gonna skip a step there. So sine pi over 2 is 1. I just take note of that. So if I put pi over 4 in, this is pi over 8. Okay. Plus cosine pi over 2 will be 0. So this is 0. Then minus of 0. Plus cosine, this is 1/4. Okay. So just be careful. Then the next one will be similarly sine pi is 0. Plus cosine pi will be -1. So this will be -1/4. Then the next one, minus of pi over 2. Sine pi over 2 is 1, so it's pi over 8. Then cosine pi over 2 is 0. So it's 0. Okay, let's just make sure you can get all these provisions. So it's pi over 8 minus 1 quarter minus of minus 1 quarter minus pi over 8. Okay, so this will give us pi over 4 square units. Okay, so that's how you do this question here proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.